Okay, so today we're going to be looking at our last lesson in chapter 4, lesson 8, and we're going to be looking at putting zeros into our product. And the question is, how do you know you have the correct number of decimal places in your product? And hopefully we recognize that we count the number of times we move that decimal out and then we move it back in the same number of times. But sometimes, right, we end up with a situation where that doesn't work out perfectly because we don't have quite enough digits in our product to be able to account for it. So we're actually going to skip forward just a little bit and we're going to take a look at this one to look at this idea. So for our problem here, we have 5/100 times 2/10, right? So remember, the first thing we're going to do is we're going to ignore all of these decimals, everything else, and really we're going to break this down to just be 2 times 5. That's what our basic fact is here. So 2 times 5 we know is 10. Now I have to move this decimal out twice. I move this decimal out once, right? And 2 plus 1 means that I need to move a decimal back in 3 times. Well, I move it once, I move it twice, and in order to move it a third time, I have to fill in this space with a placeholder. And our placeholder that we use in math is the number 0, right? So that's really all we're talking about today. Like if we have to move this decimal out 3 times, right, between these two numbers, right, because we started here and here, then when we get down here to our product, we need to move it back in 3 times. Well, here's once, twice, and then in order to be able to get it all the way over here a third time, we need to be able to add this placeholder in. And so our answer in this situation is 100th, right? Or we could leave our 0 back here and say that it's 10 thousandths, but we know we don't need that 0 back there. We do need this 0 because if it's missing, this 1 doesn't end up in the hundredths place. It instead would end up over in the tenths place, and that would not be correct. So let's apply this problem to a story problem, this idea. Here it says students are racing typical garden snails. I don't know why on earth you would race garden snails, but they are, and they're measuring the distance the snails travel in 1 minute. Chris's snail travels a distance of 2/10 foot, and Jamie's snail travels 4/10 times as far as Chris's snail. How far does Jamie's snail travel? Well, hopefully we recognize that it says right here that it travels 4/10 times as far, right? So if we have Chris's snail, right, and his snail travels from here to here, right? And this is 2/10 of a foot. Well, Jamie's snail travels 4/10 times as far, right? So if it's 4/10 times as far, it's not as far. In fact, his snail is going to end up like somewhere around in here, just a little bit under half. So to find the answer here, we need to take 2/10 and we need to multiply it times 4/10. Again, ignore our decimal, focus on our facts. And 4 times 2 is 8. Well, I would move this decimal out once. I move this decimal out once. So 1 and 1, it means that I have moved it 2 times. So I need to move it back in 2 times. Well, I start here, I go 1 and 2. And just like our previous problem, we need to fill this place in with a placeholder. And so the answer is that Jamie's snail travels about 8/100ths of a foot. So hopefully that makes some sense. Let's try a couple more problems and see how it goes. All right, let's take a look at this one here. Pause the video, give it a try, come back and see how you do. And why don't you go ahead and try both of them. All right, our first one, our basic fact is 3 times 3, which is 9. I have 1 decimal place and a second decimal place. So I need to move it once and twice. I fill it in with a 0, and my answer is 9/100ths. Right, 9/100ths. I'm going to look at the one over here to the right. All right, 3 times 5 is 15. I look here and there are 2 decimal places in that top number and a third decimal place in the bottom number. So I move it once, twice, and a third time, and I get 15 thousandths. So 15 thousandths. All right. Just for fun, let's take a look at this one and see if we can draw a model to like represent this idea. So I need to take 3/10 of 3/10. Well, remember in one of our previous lessons, we drew this model where that we cut up a block into tenths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll draw another one on for 10, right? And we started off and we shaded this in, and we shaded in 1/10, we shaded in 2/10, and we shaded in 3/10. Then we changed colors and we changed directions. We went 1/10, 2/10, and 3/10. And then really all we cared about was this part up here where we had colored both in, right? Or where we'd overlapped our colors. And this ended up being a 3x3 array. Well, 3 times 3 is 9, just like we talked about over here, right? And then each of these individual units has a value of 100. So if I have 9 of them, then I have 9 hundredths, right? So when I move that decimal that second time, that 9 goes from being in the tenths place to being over in the hundredths place, giving me my answer. All right, let's take a look at one more problem. And this problem is a basic algebra problem where we need to find the value of n, and n stands for number. So when I look at this problem, what I'm going to do is I'm going to think to myself, well, what times 2 equals 8, right? Because I have a 2 and I have an 8. Well, I know that 4 times 2 equals 8, right? So if I put 4 in right here, I would get 4 times 2/10, and I need to work that problem out. Well, 4 times 2 is still 8. I have 1 decimal place, so I'd move back in 1 decimal place, and my answer would be 8/10. But my answer over here is not 8/10. My answer over here is 800ths. So I'm going to add a decimal place to my 4, and I'm going to say that 4/10 times 2, not times 4/10 times 2/10 times 2/10 equals, well, 4 times 2 is still 8. But now I don't just have 1 decimal place, I have 1 and 2, so I move back in 1, 2, and I get my answer, right? So n equals 4/10. So again, we started with our basic fact. We figured out that 4 times 2 equals 8. We tried just putting in 4, but we didn't get a small enough answer, right? We didn't get enough decimal places. So we needed to add a decimal to our 4, move it over to the tenths place, and then we got our correct answer. All right, so that is lesson 4.8 and wraps up chapter 4. Give it a shot, and if you have any questions, let me know.